Good morning, class. We are going to continue on indices today, where we'll try to see how we do general examples in applying the 7 laws already discussed. For example, look at this one. You have to simplify 2x raised to power 1 over 2 times 3x raised to power minus 5 over 2. For you to do this, you multiply your coefficients. 2 times 3 to give you 6. Then the indices, you write one base and add your powers so that you have 1 over 2 plus minus 5 over 2. Here is the application of this law. That is x raised to power a times x raised to power b is x raised to power a plus b. That's the law here. Then you write 6 x raised to power 1 over 2 plus times minus is minus 5 over 2. You take your LCM, which is 2, LCM of 2 and 2, which is 2. 2 in 2 is 1 times the top number, which is 1, minus 2 in 2, that is 1 times 5, which is 5. 1 minus 5 is minus 4 over 2. And when you divide minus 4 by 2, it gives you x raised to power minus 2. So that you have 6x raised to power minus 2. Then, if you apply this law, x raised to power minus a, which is 1 over x raised to power a, this x raised to power minus 2 becomes 1 over x raised to power 2. The 6 remains at the top. So that your final answer becomes 6 over x raised to power 2. You can't stop here. You have to apply this negative index law to have 6 over x raised to power 2 as your final answer here. Example 2. You have to simplify square root of 16, fourth root of 16, a raised to power minus 12. You separate the number from the index this way. Fourth root of 16 times fourth root of a raised to power minus 12. Fourth root of 16 is 2. 2 times 2 times 2 times 2 is 16. That's a number that will multiply itself 4 times to give 16. That is 2. Then, you can't get the fourth root of this because it's an index. But you can express it this way. Fourth root of a raised to power minus 12 is the same thing as a raised to power minus 12 all raised to power 1 over 4 from this law here. X raised to power 1 over a is a root of x. So from this right, I can move to the left. That's what you have here, where your a here is the 4 and your x here is your a raised to power minus 12. So that when you are moving from here to here, the a will become 1 over a, which is 1 over 4, and your x is our a raised to power minus 12 in bracket. Then you apply this law. X raised to power a all raised to power b becomes x raised to power a times b. Multiply the powers, minus 12 times 1 over 4 here. So that you have 2 times a raised to power minus 3, because minus 12 times 1 over 4 is minus 3. Then you don't stop here. You apply this law, negative index law. X raised to power minus a is 1 over x raised to power a. So that a raised to power minus 3 gives you 1 over a raised to power 3. And your final answer becomes 2 over a raised to power 3. 2 over a raised to power 3. Another example, you have to simplify 27 over 125 all raised to power minus 1 over 3 times 4 over 9 all raised to power 1 over 2. Here is your solution. This is the question. Now, if you apply this law here, x over y all raised to power minus a becomes y over x raised to power a. For this negative sign to disappear, we'll reciprocate this. So, instead of 27 over 125 becomes 125 over 27 all raised to power 1 over 3. That is application of this law. X over y raised to power minus a becomes y over x all raised to power a. Leave this one the way it is. Now that there is no minus, you will apply this your law. this fractional index law, x raised to power 1 over a is a root of x. Therefore, this becomes cube root of 125 over 27, while this gives you square root of 4 over 9. You put your multiplication sign. Cube root of 125 is 5. You use 5 to multiply itself 3 times to have 125. Cube root of 27 is 3. You use 3 to multiply itself 3 times to have 27. Square root of 4 is 2. That of 9 is 3. Multiplication of fractions. You say top number times top number, which will be 10. Bottom number times bottom number, which is 9. So your answer is 10 over 9, or one whole number 1 over 9, because 9 will divide 10 one time, remaining 1 over 9. And that's how you solve it. Here is another one. You are to simplify 3 raised to power n minus 1 times 27 raised to power n plus 1 all over 81 raised to power n. Here, what you do is you express the indices in the same base. So we express them in base 3. That is these 3, 27 and 81. We express them in base 3. This one is already in base 3, so just leave it. 27 in base 3 is 3 raised to power 3. Then you put your n plus 1 in bracket like this. 81 in base 3 is 3 raised to power 4. Then see your n. Now, when you check this top, you can apply this law here. X raised to power a times x raised to power b equals x raised to power a plus b. So you write one base, which is 3, and add your powers to have n minus 1 plus 3 open bracket n plus 1 for your numerator, all over 3 raised to power 4n. You don't stop there. You can apply this division law, x raised to power a divided by x raised to power b, to give you x raised to power a minus b. So here you can write one base and subtract your powers, so that you see the powers at the top, which is n minus 1 plus 3 in bracket n plus 1, close it, minus this one. Then you open your bracket, 3 raised to power n plus minus 1. When you open this bracket, 3 plus 3 times n is plus 3n, plus times plus plus, 3 times 1, 3, minus 4n. You regroup now. The n's, bring them together. So we have no change of sign. 3 raised to power n plus 3n minus 4n. Then the constant, you write them minus 1 plus 3. This will give you n plus 3n is 4n, minus 4n is 0, 0 minus 1 minus 1, minus 1 plus 3 is minus 2, and we have 3 raised to power 2, which is 9. And that's how you simplify this. You can see how we've solved it. Applying more than a law. You express them in the same base. You apply this law where you have this. You add your powers after writing one base. Then you apply this one. You write, since the bases are the same, write one base and subtract this power from what you have here, and continue your simplification. The answer will come out. Now, here is another example before we stop today. You are to simplify this. See it here. You see the base 25, 25. Write 1. Subtract your powers because of division sign. That is applying this law. Here, your base is 1 over 5, 1 over 5. Write 1. Then you will add your powers, minus 7 over 6 plus 1 over 6. That is applying this law. Now, to simplify this, you look for LCM of 3 and 6, which is 6. 3 in 6 is 2 times 2, which is 4, minus 6 in 6 is 1 times 1, which is 1. So you have 25 raised to power 4 minus 1 over 6. For this, we have 1 over 5 raised to power, the LCM of 6 and 6 is 6. So 6 in 6 is 1 times the top number, which is minus 7, plus 6 in 6 is 1 times 1, which is 1. So that you have 1 over 5 all raised to power minus 7 plus 1 over 6. 4 minus 1 is 3 over 6. Minus 7 plus 1 is minus 6 over 6. 3 over 6 is 1 over 2. 3 here 1, 3 here 2. So that you have 25 raised to power 1 over 2. Minus 6 divided by 6 is minus 1. So that you have 1 over 5 all raised to power minus 1. Now when you apply this law here, x raised to power 1 over a, which is a root of x, this becomes 25 raised to power 1 over 2 becomes square root of 25. Similarly, when you apply this law, x over y all raised to power minus a, which will be y over x raised to power a. For the negative sign to disappear, you say 5 over 1 raised to power 1. Square root of 25 is 5. 5 over 1 is 5 raised to power 1. This is 5. 5 raised to power 1 is 5. 5 over 5 is 1. And this is how you solve it, applying your laws. So generally, we've been able to apply those laws to solve the following few examples.